So let's take a look at graphing logarithms. So remember, logarithms are the inverse of exponential functions. So we would expect, thinking about what we know about inverses and what we know about exponential functions, so we'd expect the graph of, right, a logarithm to be a reflection over the line, right, y equals x. Okay, so what I have for us to get started, here's a graph of 2 to the x. I'm sorry, yeah, y equals 2 to the x. Here's the line y equals x, and we're going to use, right, our 2 to the x graph to come up with some points on the graph of log base 2 of x. Log base 2 of x. Okay, so let's just grab some points. So I'm going to look at x and f of x and just grab a couple of those points that are easy to pick out. So let's see, I've got 0, 1. So if x is 0, y is 1. So then I know on the inverse, let's see, x and g of x, right, those things swap. So 1, 0. Right, so this point 0, 1 becomes, oh, those are, okay, so we'll have to guess. There's 1, 0. The marking's 0 by 2, so make sure you get that. Let's see, what's another point up here on my 2 to the x graph? Let's see, I've got, I've got 1 and 2. So that means on my log function, it would be 2, 1. So if I go to 2, right, and up at 1, there's another point on my inverse. Okay. So just reading off these points along my 2 to the x. So here, I'll just kind of fill in that guy. We're going to have to be doing a little bit of guesstimating, and then we'll find them on our inverse function. So let's see, that point up there was if x is 2, y is 4. So on the inverse, right, it would be 4, 2. So 4, 2. Well, we can kind of see, right, a basic shape coming out right here. Now, if we sort of think about like folding this graph over, let's think about what other things are going to happen. Where is this part? This part over here where my x's are negative on 2 to the x are going to come over here and be negative y's on my log base 2 of x. And then right here, as it's going up steep, it's going to be down here and going out right a little bit flatter. So the one more point that I know of, I could do 8, 3. It's not on my 2 to the x, but since we've done a couple of logs, we can fill that in. So this here, this is our graph of y equals log base 2 of x. So if you are graphing these, and I'm not sure what Desmos does with it, if you need to do a change of base, if you're doing it on a graphing calculator, you'll need to use your change of base property to get a graph of it. So if I go to my y, well, first of all, let me check my mode since I just grabbed this. Okay, we're in function, degrees, I don't care. So if I go to y equals screen, if I want to graph log base 2, then I need to do, right, natural log of x divided by natural log of 2. Right? Or, and I'll show you, right, it could be common log as long as you're consistent. I'm doing this because those should be the exact same graph, right? So when I hit graph, I should see the same thing. I'm going to check my window real quick. That's fine. Hey, there it is. So you saw it in blue and then it traced over it in red. And it's essentially the same graph, although be careful, right? Because of just right limitations of pixels on your screen, it looks like it dives in here at y equals maybe -3 and then it disappears. That's just because, right, they're so close to that y-axis that we can't distinguish on our calculators, right? But we know, you and I know, that it continues on forever, in which case we call that an asymptote. Okay, so here we go. For the function y, or f of x equals log base b of x, where b is a real number greater than 1, right? The domain and range, so the domain, right, we can only take logs if it's a positive number, so bigger than 0, not 0. And then my range, the y's we get out all of the y's. So just like with our exponential function, right, it swapped. For my exponential function, 2 to the x, right, the domain here was all real numbers, and the range, right, was all positive numbers. And so then for its inverse, as we'd expect, those two, right, switch positions. Long run behavior, right, as x gets big, what happens to our y values on our log function? Right, so x gets big out here. What are those y functions doing? I know it's tempting to say, well, it looks like it's flattening out. It doesn't. It grows on forever. So the y gets big. Don't worry, I'm gonna help you out there. It gets big, but it gets big slowly. So something you'll talk about in calculus quite a bit, right? Log functions, right? They have a big growth spurt at the beginning, and then they kind of grow slowly after that. Right? Grow slowly as x gets big. Okay, they grow, but they grow slowly. Okay, asymptote. I do have an asymptote. Right? It's over here on the graph. It's this negative y-axis. I'll just say the y-axis. Okay. And then the intercept, there is no y-intercept. But the x-intercept is 1, 0. Okay, so now let's use what we know about right, our shifts to graph y equals natural log of x minus 1 plus 4. Let's talk about domain, range, asymptotes, and intercepts. So I'm just going to come down here. I'm going to do a quick sketch of so natural log, right, that's log base e. E's really close to 2. Our graph's going to look really close to that one, right, that we just had. So here's just kind of a basic shape of natural log of x. So then what are we going to do to it here? We're going to shift it right 1 and up 4. We're going to shift the whole graph. We'll shift all of the points, but what can we think about shifting? What point and what asymptote, right? So when we shift, we're going to shift the x-intercept and the asymptote. So my x-intercept is going to shift to the right 1. So it'll be at 2, 0. And then up 4, 1, 2, 3, 4. So now that point goes to 2, 4. My asymptote used to be at x equals 0, right? But now it's going to be at x equals 1, or when x minus 1 equals 0, right? So x equals 1, that asymptote shifts over to the right 1. So my new graph, I'll shift my asymptote right here to where x equals 1. At x equals 2, I know my graph is up here at 4. And other than that, it's just going to have that same basic shape. So it'll have some sort of x-intercept in here. Could we find the x-intercept? Sure we can. Okay. So does it have a y-intercept? No, right? Because we shifted to the right, so we didn't get a y-intercept. Right? If we would have shifted our graph to the left, then sure, we may intersect the y-axis. This one didn't. Okay. What did I say? X-intercept, so the x-intercept y equals 0. So 0 equals natural log of x minus 1 plus 4. Subtract 4 from both sides. How do we undo natural log? Yep, e to the both sides, or do the little loop-de-loop, right? So e to the negative 4 equals x minus 1. Add 1 to both sides. So our x-intercept is 1 plus e to the negative 4. So that's this point here. 1 plus e to the negative 4 comma 0. Okay. Domain and range. Domain and range of our shifted function. Domain, right, think about your asymptote. So instead of being 0 to infinity, it's going to be 1 to infinity. Our range, all real numbers. And our asymptote, I wrote over already. It's supposed to be an x. X equals 1.